second one is a point on the line. So suppose you have three axes. So remember that you are in
a
space,
vector
three-dimensional space R
parallel to that line.
So you consider a line in space. So suppose that this is your x-axis, this is your y-axis, and this is your z-axis. So of course, and you consider a line in space. So you consider a line like this, a straight line L, and suppose that a given point is P0 on the line. So suppose there is a point P0 is given on the line. Suppose P0 is a point on the line, and suppose you are given with a vector V parallel to the line. So suppose you have a vector V parallel to the line. So this is the situation. So now the set of all points on P on the line L. So suppose you have a point P. Suppose it is a general point. So you let L be a line. L be a line. Let V equal to V1I plus V2J plus V3K, be a vector parallel to the line L. So let P0 equal to X0, Y0, Z0. This is a point on the line P, line L, and let P equal to X, Y, Z. These 2 points belongs to L. So these are 2 points on the line L, and from the figure you can see that the vector P0P. So you consider the vector P0P. So consider the vector P0P. So that vector is actually parallel to the vector V. So you have vector P0P is parallel to the vector V. So that is, you can write it as a scalar multiple of the vector P, where as t varies, you are getting different points on the line. So for example, suppose t is 0, you are getting P0 itself, and when t is 1, you are getting a vector this one with the same length as that of P. So when t is equal to 1, you are getting this point. So as t varies from 0 to infinity, you are getting different points on the line, on this line, and as t varies in the negative direction, you are getting the points in this direction. So you can say that t belongs to minus infinity. So we have P0P is equal to TV. So this gives a description of points on the line L. Now suppose, so let R0 be the position vector, of P0, and R of t. So you may take, since x, y, z varies, you can take it as it depends on t. R of t be the position vector of P. Be the position vector of P. Then from this equation 1, so you take this as equation 1. So from this equation 1, you have R of t minus R0 this is equal to some t times b, or you can say that r of t is equal to r naught plus tv. R of t is equal to r naught plus tv. So this is known as the vector equation of the line in space. Equation of line in space. It's known as the vector equation of line in space. Now you have position vector of x is, we have r of t, the position vector of x, y, z is xi plus yj plus zk. So that is the position vector of x, y, j, and you have r naught of t, the position, sorry, r naught, so it is a point, you have r naught equal to x naught I plus y naught j plus z naught k. You have this. Then take next page. So from equation 1 you have x I plus yj plus zk minus x naught I plus y naught j plus z naught k is equal to x. So that is actually equal to tv, t times v1i plus v2j plus v3k. This you have v1i plus v2j plus v3k. So from this equation you have x minus x naught into I plus y minus y naught into j plus z minus z naught into k. This is equal to tv1 I plus tv2 j plus tv3 k. So this implies x minus x naught is equal to tv1, x minus x naught equal to tv1, y minus y naught equal to tv2, and z minus z naught equal to tv3. That implies x is equal to x naught plus tv1, y is equal to y naught plus tv2, and z is equal to z naught plus tv3, where minus infinity less than t less than infinity is the parameter. So this is known as the parametric equation of the line. So this is known as the parametric equation of the line. Of the line. So how vector equation of the line, that is given by r of t. So you have two equations. First one is the vector equation. So you have vector equation. What is the vector equation? R naught, sorry, r of t is equal to r naught plus t into b, where this is r is the position vector of p, this is the position vector of r naught is the position vector of p naught, and v is the vector, this is the vector parallel to the line L, and t is called the parameter. So where t belongs to minus infinity plus infinity. So this is your vector equation of the line, and you have the parametric equation of the line. Now we do some problems. Okay, so we'll create a new page. So do some problems. The first problem is find the parametric equation of the line through minus 2, 0, 4. Question number 1. Find the parametric equation of the line through minus 2, 0, 4 parallel to vector v equal to 2i plus 4j minus 2k. So this is the first question. So answer. Answer. So what are given things are, you have b naught is given to be minus 2, 0, 4. So here b naught, and the vector v is given as 2i plus 4j plus minus 2k. So these two things are given. You have to find the parametric equation of the line, and x is equal to x naught plus tv1, y is equal to y naught plus tv2, and z is equal to z naught plus tv3. This is the parametric equation. So minus infinity less than t less than infinity. So this is the parametric equation of the line. So here given x naught is given to be minus 2, y naught is given to be 0, and z naught is given to be 4, and the v1 is 2, v2 is 4, and v3 is minus 2. So you can use that. So you have x naught equal to, so these are the given things, minus 2, y naught equal to 0, and z naught equal to 4, minus 4, sorry 4, and you are given with v1 equal to 2, v2 is equal to 4, and v3 is equal to minus 2, v3 equal to minus 2. So these things are given. So parametric equations are x is equal to x naught plus minus 2 plus tv1, t times v1. So this you can write it as 2t, and y is equal to y naught plus, so 0 plus 4p, and z is equal to z naught plus 4 plus minus 2t. So actually this is 4 minus 2t, where minus infinity less than t less than infinity. So the parametric equation of the required line is, parametric equation of the given line is what? X of t. You can write it as x of t is equal to minus 2 plus 2t, y of t that is equal to 4t, z of t that is equal to 4 minus 2t, where minus infinity less than t less than infinity. This is the answer to the first question. Now we have a second question. Now so this is the case when a point and a vector is given. A point and a vector is given. Now we are switching on to the case when 2 points on a line is given. 2 points on a line is given. So that's the next question. So consider a new page. Yes. So the question is question number 2. Find the parametric equation of the line parametric equation of the line through line through 2 points minus 3, 2, minus 3 and 1, minus 1, 4. Minus 1, 4. Minus 1, 4. Now, take winning. Okay, answer. So here the situation is like this. You are given with a line L. They are given with 2 points. Suppose that P is the first point and Q is the second point. So the vector PQ, so this vector PQ will be a vector in the direction of the line. Vector PQ will be a vector in the direction. So that will PQ will give a vector in the direction of the line L. So you let P to be the point minus 3, 2, minus 3, minus 3, 2, minus 3. So that is the point P, and suppose that Q be the point 1, minus 1, 4. Q be that point 1, minus 1, 4. 1, minus 1, 4. Okay. Then you have vector PQ is parallel to the line L, and vector PQ is position vector of P minus position vector of Q. So PV of Q, position vector of Q minus position vector of P. So this is equal to position vector of Q is minus 3, sorry, I. Position vector of P is I minus J plus 4K minus position vector of P is minus 3I plus 2J minus 3. So from this you will get 1 minus minus 3. So 1 minus minus 3, so 4I minus J minus 2J, so you will get minus 3J. 4 minus 3, 4 minus minus 3, so this will be 7, 7. So you have the vector, so this is vector V. Now you can take any point, either P or Q, as the given point. So for example, so let P naught or P naught for the equation P naught, this is equal to x naught y naught z naught, that is equal to 1 minus 1 4, 1 minus 1 4, suppose this is the, so you have the vector V equal to the vector V equal to 4I minus 3J plus 7K, and P naught is the second point. So we create a new page. So how the given vector V is 4I minus 3J plus 7K, 4I minus 3J plus 7K. So this is the vector V, and we have the point P naught, that is equal to x naught y naught z naught, that is equal to 1 minus 1 4, 1 minus 1 4. So this is, so you know the parametric equation of the line is x of t equal to x naught plus TV1, y of t, that is equal to y naught plus TV2, and z of t, that is equal to z naught plus TV3, where t belongs to minus infinity. So this is the parametric equation of the line. So here, so from this you can see that x of t is equal to your 1 plus the vector is 4I minus 3J plus, so it is 4t. So you have 4t, and y of t is y naught plus, so you know y naught is minus 1 plus TV2. So we can minus TV2. V2 is minus 3. So minus 3t. Minus 3t. And z of t, this is equal to 7 plus 4 plus it's 4 plus V3 is 7, so 4 plus 70. So t belongs to minus infinity. So this is the parameterization of the line segment, line. Now the next question is parameterize the segment joining 3, 2, minus 3, 1, 4, minus 1. So what is the segment, parameterization of the segment joining? So it's number 3. So number 3, parameterize the segment joining P minus 3, 2, minus 3, Q 1, minus 1, 4. So this is the question. So here again the problem is the same as the previous one, but you have to find the parameterize the segment. So suppose that this is the point P, this is the point Q, and parametric equation gives the equation of the entire line L. Entire line L. So here you have to find the equation of this much segment. So what is the equation of this much part? So that's the question. EQ. Now you have x is equal to 1 plus 40, x of t is equal to 1 plus 40, y of t is equal to minus 1 minus 3t, minus 1 minus 3t, and z of t is 4 plus 70. 4 plus 70. 4 plus 70. So what happens when t equals 0? When t equals 0, you are getting this point Q. So when t equals 0, t equals 0 implies x of t equal to 1, x of 0 actually. X of 0 is 1, x of y of 0. Y of 0 is minus 1 and z of 0, that is equal to 4. So when time t equals 0, you are at here. Time t equals 0. When t equals 0, we are getting Q, the point Q. And when time t equal to 1, what you are getting? Time t equal to 1, you have t equal to minus 1, and time t equal to minus 1, you have x of minus 1 is 1 minus 4, so that is minus 3. Then time t equal to minus 1 plus 3, so we are getting 2. So y of write it in next page. Start with a new page. So we have to parameterize the segment. So you have the line L, and you have the point P, and you have the point Q, and P is the point minus 3 to minus 3, and Q is the point 1 minus 1 4, 1 minus 1 4. So we have the equation of the line x of t. X of t is 1 plus 40. Y of t is minus 1 minus 3t, and z of t is 4 plus 70. 4 plus 70. So you have to parameterize the segment PQ. So you have to find what is the variation of P for the segment to get the segment PQ. So actually you have to find the equation of this much portion. This much portion. You have to find the equation, so which is the part of that line. You find this much. What is the equation of that much part? And so as we have seen previously, so x of 1 is 1, sorry, x of 0. X of 0 is 1, y of 0 is minus 1, and z of 0 is 4. Z of 0 is 4, and x of minus 1 is minus 3, y of minus 1 is minus 4, sorry, this, sorry, yes. So when it is y of minus 1 is minus 1 plus 3, so it is 2. It's 2, and z of minus 1 is minus 3. This is equal to 4 minus 7 is minus 3. So when time t equal to, when time t equal to 0, not worry about time. Suppose when the parameter t, so you can say that when the parameter t equal to 0, we have at q, and when the parameter t is minus 1, we are at p. So the equation of the line segment PQ is PQ is x of t equal to 1 plus 40. Equation of the line segment or parameterization of the line segment is x of t is equal to 1 plus 40 y of t, that is equal to minus 1 minus 3t z of t is equal to 4 plus 70, where minus 1 less than or equal to t less than or equal to 0. So you have, this is the parameterization of the segment PQ. Of the segment PQ, not the vector, the segment PQ. Okay. So that is the solution. So this is the parameterization. So this is parameterization. So with this we can stop here and we will discuss the remaining portions in next class.